Our today topic is basic elements of Java. Like any other programming language, the Java program language is defined by grammar rules that specify how syntactically legal constraints can be formed during the language element, and by semantic definition that specify the meanings of syntax legal constructs. Basically, in Java, we have two types of rules. First one is syntax and second one is semantic. Syntax rules define any statement is legal or not, and semantic rules define meaning of that syntax. For example, if we declare a variable int a and not place a semicolon at the end of this, then it will be illegal. So each statement must have a legal syntax. Syntax rules, semantic rules basically defines the meaning of statements. For example, we are writing C equals to A plus B. So here semantic rules define the meaning of this statement that add the variable of A and B and store the result in C. So there are a number of elements in Java program that we use while developing our Java program. So some basic elements of Java like tokens, identifiers, keywords, literals, operators, and variables. First one is tokens. Tokens is the smallest element of a program that is meaningful to the compiler. So token is basically smallest element in program, like it can be one word. For example, our semicolon. If we forget semicolon, then there will be a error. So basically token is a small unit. It can be one word, two word, as so much. So tokens can be classified in various categories like variables, operators, literals, special characters, keywords. So now discuss about these terms one by one. Firstly, we have identifiers. A name in a program is called an identifier. Identifier can be used to denote classes, methods, variables, and labels. In simple words, a name in program is called identifiers. For example, we have a identifier A. We can use it for a variable name. Any function name is also our identifier. In Java, an identifier is composed of a sequence of characters, where each character can be either a letter, digit, underscore, or any currency symbol. So when we want to declare a identifier, we can use letters like A to Z, then digits and underscore, currency symbol mentioned in bracket. We can use these symbols only. We cannot use @ symbol when we want to define an identifier. So first character in identifier cannot be digit, means our identifier name cannot be started with the digit. Identifiers in Java are case sensitive. For example, we writing price, all letters in capital lowercase, and capital P and remaining letters in lowercase are two different identifiers. Here are some examples of identifiers. First one is number, all in lowercase, then capital N and remaining in lowercase, sum underscore $, bingo $underscore 100. These are the legal identifiers because here no identifier is started by a digit, and symbols used in identifier names, we can use these symbols. So here are some examples of illegal identifiers. First one is 48 Chavi. This is illegal because it is started by a digit. Then all @ hands. So we cannot use special symbol @ in identifier name. So that's why it is illegal. Then grand hyphen sum. We cannot use hyphen in our identifier name. So that's why these are illegal. Then our next topic is keywords. Keywords basically reserve identifiers. Keywords are reserved identifiers that are predefined in the language and cannot be used to denote other entities. All the keywords are in lowercase, and incorrect uses result in compilation error. In Java, there are some keywords. We cannot use these keywords as our variable name, function name. And here, one main point is all keyword will be in lowercase. So we cannot use reserve word as identifiers. There are some keywords in Java like abstract, asset, boolean, break, byte, case, catch, char, class, continue, default, do, double, else, extends, final, finally, float, for, if, implements, import, instance of, int, interface, long, native, new, package, private, protected, public, return, short, static, strict, FP, super, switch, synchronized, this, throw, throws, transient, try, void, volatile, while, null, true, and false. These are keywords, and we cannot use these keywords as our variable name and function name, class name. For example, here, if is used for condition checking, true and false used to store Boolean values. So these keywords are reserved for some purpose. For example, int is used for data type integer, so we cannot use these keywords for other purpose. So next element is literals. Firstly, we study about identifiers. Identifiers basically we can say our name, and then keyword are reserved for a specific purpose. We cannot use keywords as our variable name, function name, class name. So now the another element is literals. A literal denote a constant value. That is the value a literal represent remain unchanged in the program. For example, we use 2, it is integer, and we use literals to assign value to the variables. Basically, literals we can say any constant value like 2, 3, it can be float like 1.5, it can be boolean like true, false, it can be string like our name. So literals basically are constant value. Literal represent numerical, character, boolean, or string value. In addition, there is a literal null that represent null reference. So there can be null literal which will contain a null reference. So literals are used to create values that are assigned to variables. So we use literals to assign values to variable. For example, here we have integer literal like 2. So when we declare and define our variable like int a, means we declaring a variable of integer type whose name is a, and here we assigning this literal to the variable. So basically literals are used to assign the value to the variable. So there are literal can be integer, float, boolean, and character literal. So there types of literal are integer literal, which contain in which literal are without decimals, we can whole number, and floating point literals means the decimal numbers. Character literals deal with the characters like alphabets. String literals contains a sequence of characters, and Boolean literal contain a Boolean value. So now discuss about these types one by one. So firstly, integer literals. An integer is a whole number without any decimal. So in integer literal, there will be whole number without any decimal number. So for integer literal, we have four data types. Like if we want to define a literal and assign value to the variable, there will be four types like integer, long, byte, and short. We will learn about these data types in our topic data types. What is difference between int, long, byte, and short? So literal integer can be stored in four categories. It can be stored as four data types like integer, long, byte, and short. By default, data type of integer literal is always int, but it can be specified as long by appending L or I to the integer value. If we want to specify our literal long, so we can append L or small l, capital L or small l at the end of our value. Here, if we want to define 2000 long literal, so we can place capital L or small l at the end of our literal value. So without suffix, the long literals 2000 L and 0 small l. So we can store our integer value like in decimal, octal, and hexadecimal. For example, we want to use literal 8. So in decimal, we simply write 8. But if we want to write octal, so octal value of decimal 8 is 10. And we have to append 0 at the starting. 0 denotes that this is the octal value. So if we want to use hexadecimal value, so hexadecimal value of 8 is 8, and we have to append 0x at the starting. So 0x will tell the compiler that this is a hexadecimal value. So we can use decimal format, octal format, or hexadecimal format for our integer literal. Basically, if we use decimal format, we simply place our value. So for octal, firstly we convert our decimal value into octal, and 0 will be appended at the starting. 0 will tells the compiler that this value is in octal format, and in hexadecimal we have to append 0x at the starting. So the next type of literal is floating point literals. It is used to represent real number. We can say decimal numbers. For storing a floating point literals, there are two types of data type, float and double. By default, data type of float point literal is double. So here we can append suffix capital D or small d for double, and for float we can append capital F and small f. For scientific notation, in floating point literals, we can use E for exponents. For example, we want to store 194.9 multiply 10 power minus 2. So we can write it as 194.9. Then we use E stand for exponent, and here we write power of 10 like minus 2. So we use E for exponent. Here is some example of floating point literals. Firstly, for double literals, here we writing small d, capital D. It will denote that this literal is of a double data type. Then for float, we use capital F, small f. Here we writing like 0d, 0f. So here compiler will append decimal by automatically, like 0.0, 0.0. Like if we writing here 2d, then compiler will automatically convert it into floating point like 2.0. So note that decimal point and exponent are optional. We can write floating value without decimal and without exponent. Exponent is not compulsory. So as per our requirement, we can use, as per our requirement, we can remove it. So at least one digit must be specified. Then Boolean literals. Primitive data type Boolean represent truth value true or false. They are denoted by reserve literals true or false. In keywords, here some keyword like true and false. That true and false is used by Boolean data type for storing truth value true and false. Then character literal. A character literal is quoted in single quotes. So we write our character literals in a single quote. And data type for character literals are char data type. There are some valid character literals like capital A in a double quote. We can also use symbols, but in a single quote, these are treated as character literals. So space can be also used. /n for next line is also write as a character. So for any character literal, we have to write our value, our character into single code. Then string literals. A string literal is a sequence of character which must be quoted in quotation marks and which must occur on a single line. So string literal can be write in double quotes and it must be of single line. All string literals are objects of string class. The next element we use in our Java program is operators. Basically, operators in Java is a symbol. We use operators to perform any operations on our operands. There are many types of operators in Java, like unary operator, arithmetic operator, shift operator, relational operator, bitwise operator, logical operator, tertiary operator, and assignment operator. We will study about these types in our topic operator. Here we just learn about what is operator and types of operator. Basically, operator is used to perform a specific operation. For example, plus is used for addition, minus is used for subtraction. So our next topic is variables. Variable is the name of reserve area allocated in memory. In other words, it is a memory of a memory location. So basically, variable is a name of a memory location. It is combination of a variable, which means its value can be changed. For example, we using a variable like int a. Here a is our variable name. We can store any value in the variable. We can store any literal, we can say. So for example, here int a equals to 10. So initially a storing value of 10. and then we writing like a equals to a plus 10. So now the value of a variable will be 20, because after adding 10 value become 20. So value of a variable can be changed. So this is the all about elements of Java. So our next topic is Java variables. As we studied in elements of Java program, variable is name of a memory location. So there are different types of variable in Java. Firstly, we learn about what are Java variables, and then we learn about the different types of variables in Java. So firstly, variable is a container that hold the value while the Java program is executed. Basically, Java variables like a container in which we store our value. A variable is assigned with the data type. When we declare a variable, we assign a variable name with the data type. Variable is name of a memory location. So variable is basically name of a memory location where we can store our values. Variable is name of a reserved area allocated in memory. It is combination of a vary plus able, which means its value can be changed. So firstly, we declare a variable and define its initialize variable. So after that, when we perform any operation on the variables, our value can be changed. There are three types of variable in Java: local, instance, and static. So firstly, we will learn about how to declare a variable and how to initialize a variable. Variable is very important, we can say, element in our program when we implement our program in Java. So firstly, we will declare a variable. Without declaration, we cannot use any variable. If we try to do this, an error message will be displayed on the screen. So our variable cannot be used until and unless it is declared. The data type were we assigned during declaration define the type of value it can hold. So we assign a data type to variable, and we can store value of that data type in variable. For example, if we declaring variable of int type and we want to store our float value, it cannot be possible. So variable can store a value of its data type. So various data types such as int, float, string, character, boolean, long, double can be assigned to a variable. Firstly, journal syntax to declare a variable in Java. Firstly, we will write our data type and then variable name. So here example like int a. So firstly, we writing its data type. Here data type int means integer data type and a is a variable name. So for declaring variable, we firstly write in data type and then variable name. So now initialization of a variable means we here we will store any value in a variable. We assigning our default value to variable is called initialization of that variable. A variable can be initialized both during declaration and during the later stages of program as required. So we can initialize our variable when we declare our variable, and if we skip it, if we forget to initialize, then on later stages we can initialize our variable. So here I am writing a syntax for both during declaration and at later stage. So firstly, initialization during declaration, like firstly we will write our data type and then variable name. For example, I am writing here our data type int variable name a. So int a equals to then variable value. For example, we want to assign a 10 value to our integer variable. Then we will write like int a equals to 10, then semicolon, because each statement in Java will end with the semicolon. So initialization at later stage, for example, firstly we declare our variable like int a. We declare our variable but not assigning any value to the variable, but after that we want to initialize our variable. Then firstly we will write our variable name equals to variable value. So here we will write a equals to 10. So initialization at later stage, in this firstly we have to declare our variable. Here I cannot write like b equals to 10, it will generate error. So firstly we have to declare our variable and then we can assign a value, and we can also assign a value at the time of declaration. There are three types of variable: local, instance, and static. So now we will study about each one by one. Firstly, local variable. A variable declared inside the body of a method is called local variable. When we define a function, when we create a function, in body of that function, when we declare a variable, that variable is known as local variable. You can use this variable only within that method, and other method in class are not even aware that variable exists. So in which variable, which function, in which method you declare your variable, you can use in that function only. Outside the function we cannot use local variables. A local variable cannot be defined with the static keyword, so we cannot define our local variable static. So the scope of local variable is inside the function, inside the method. Then next type is instance variable. A variable declared inside the class but outside the body of method is called instance variable. It is not declared as static. So we cannot declare instance variable as static. It is declared inside the class but outside the body of a method, but outside the function. So it is called instance variable because its value is instance specific and is not shared among instances. For example, we creating object, two objects O1 and O2. So if O1 is using instance variable, then O2 cannot use this instance variable. It will use another instance variable. So instance variable is not shared among instances. The variables are created when an object of class is created and destroyed when object is destroyed. So when create a object, then this variables will be created, and when our object will be destroyed, this variable will be destroyed. So scope of this variable will be depend upon object. Then our last topic of last type of variable is static variable. A variable that is declared as static is called static variable. It cannot be local. You can create a single copy of static variable and share it among all the instances of a class. Memory allocation for static variable happens only once when the class is loaded in the memory. So if we create a class, the memory allocated to static variable only once. Although we create 10 object, 100 object, 200 object, static variable will be allocated memory only once. So in instance variable, if we creating 10 objects, then 10 instance variables will be created. If we create 100 objects, then 100 instance variable will be created. But in static, memory is allocated only once and used by all the objects. At last, there is an example which demonstrate different types of variable. Firstly, here we writing a class A, public class A. In the body of this, firstly we declare and initialize static variable. Static int m equals to 100. So this variable memory location m will be allocated only once. So memory is allocated to variable m will be only once, and it will be used by all objects. So void method. So in body of a method, a variable is declared. This is known as local variable, and we can use in n inside this method. We cannot use n outside the method. So then in main function, we declaring a variable. So this is known as instance variable. For example, we creating a object 2 of a class, then 2 times this variable will be allocate memory, and for corresponding object it will be used. For example, we have object like T1 and T2. So here data, I'm writing just D. Like D1 is used by T1, and another data, copy of data will be used by T2. So T2 cannot use this variable, and T1 cannot use this memory location. We can say this copy of instance variable. So corresponding copy of instance variable will be used by object. So this is all about variables and their types. Our next topic is data types. Data types specify the different size and value that can be stored in variable. So basically data type define size, means how many bytes will this data type occupy, and value that can be stored. For example, int data type can store integer value, float data type can store decimal value. So basically data type specifies the size and value that can stored in variable. There are 2 types of data type, primitive and non-primitive. So primitive data type, we have a Boolean, char, byte, short, int, long, float, double, and non-primitive classes, interfaces, and array. So main difference between primitive and non-primitive data type is for storing value. In a primitive value data types, value is stored in data types. Value is stored, but in non-primitive there is a reference value. We will deal with the reference, like in array we work with indexes like I0, and then value is return. So actual value is not stored in array. We deal with the references. Primitive data type primitive type variable contain actual value of a variable, whereas non-primitive type variable contain an address that indicate the memory location of actual object. So in primitive, actual value is stored in variable, but in non-primitive, address is stored in variable at which our value is stored in memory location. Primitive data types are building blocks of data manipulation. There are most basic data types available in Java language. So firstly, we have 2 types of data type like primitive and non-primitive. Then in primitive, there can be of 2 type, Boolean and numeric. Boolean will store a Boolean result like true and false. So here in Boolean, there is only one data type, Boolean. So in a numeric, there can be character and there can be numbers. So numeric can be of two type, character and integral. So in a character we have only one data type, char, which will we can use for storing characters. So integral, in this we can store two types of value, like whole number and real number. So there is also two type, like integer and floating point. Integer is used to store a whole number without decimal, and float is used to store a real number. So in integer there are four types of data type, and in floating point there is two types of data type. So now we will study about this one by one. Firstly, we have a Boolean data type. Boolean data type is used to store only two possible value, like true and false. This data type is used for a simple flag that track true and false condition. So where we use Boolean data type? Boolean data type is used to store flag values that track true or false condition. We can also use Boolean data type for decision making and looping. So here example of a Boolean. If we want to use a Boolean data type, firstly we write a data type like Boolean, then our variable name. Variable name can be anything. Here is flag, you can use any as per your requirement. And here we assigning true or false value. So here in example we are assigning false value. Boolean can store only two values, true or false. Except these, we cannot store any value in a Boolean. So then next is character type. For storing a characters, we use char data type. So it is represented by 16-bit unsigned integer. So it is used 1 byte. So in every data type, there firstly size of data type means how many bytes a data type will use, and its range. So its range lie between 0 to 65535, like 2 power 16. So char data type is used to store characters. So if we want to use character type, means if we want to work with character type variable, then firstly we will write char, then our variable name. Here variable name is letter, and then we assign a value, and any character value will be written in single quotes. So here A is written in a single quote. If we skip it, an error message will be generated. So next is integer type, to store the whole number without fraction. So there can be a four type. There are four type of integer type, like int, short, byte, long. So integer can store positive value as well as negative values. So now we will study about these four types one by one. There is only difference between memory, like integer use two bytes, short use 1 byte, long use 4 bytes, and their range. These four types are used to store whole numbers without a fraction. So firstly, int data type. It uses 4 bytes to store integer, and its value lie between minus 2 power 31 to 2 power 31 minus 1. So its minimum value will be negative and maximum value will be positive. So its default value is 0. So we can use int data type where there is no problem about memory, because it uses 4 bytes. And if we have large amount of memory, then we can use int data type. So if we want to working with int data type, so firstly we have to write int keyword and then our variable name. It can be anything as per a requirement. Here I'm using a equals to then our value we want to assign it. So then byte data type, it use 1 byte. Its range lie between minus 128 to 127. So minimum value will be minus 128, and maximum value we can store here is 128. If we want to store 129, then byte data type will not store that value. We have to use int like short. So minimum value and maximum value we can store byte data type is minus 28, minus 128 and 127. So default value here is 0. So byte is 4 times smaller than integer. So if we want to save our space, we want to save our memory, then we can use byte data type. So if we want to use byte data type, firstly we will write byte keyword and then our variable name equals to our value. Then short data type, it use only 2 bytes, and here value range lie between -32 768 to 32 767. So its default value is 0. So here also minimum value we can store is negative -32 768, and maximum value we can use 32767. So if we want to store 32768, then short data type will not work. So short data type can also be used to save memory, just like byte data type. It is 2 times smaller than integer because integer use 4 bytes and short use 2 bytes. So if we want to use variables of short data type, then first we have to write a keyword short, then our variable name as equals to value. Now long data type. Long data type use 8 bytes and its value lie between 2 power 63 to 2 power 63 minus 1. So here minimum value will be -9 2 2 3 3 7 2 0 3 6 8 5 4 7 7 5 8 0 8, and maximum value can be 7 2 2 3 3 7 2 0 3 6 8 5 4 7 7 5 8 0 5. So long data type is used when you need to range of value more than provided by int. So when we want to store a very large value that we cannot use in int, so we use a long data type. So for this we can use long keyword, then our variable name equals to value. Then our second data type, floating point type. It is used to store decimal values because in integer we cannot store decimal values. So for storing decimal values we can use a floating point data type. So here we have two data type, float and double. So if we use float data type, it require 4 bytes, and here digit of a precision are 7, means after decimal there will be 7 digits. So range lie between -3.4 into 10 power 38 to 3.4 into 10 power 38. So if we want to use float data type, then first we will use keyword float, then our variable name equals to value. Like float f1 equals to 234.5. Then double data type, it requires 8 byte for storage, and here precision are 15, means after decimal digits will be 15, and its value range lie between -1.7 into 10 power 308 to 1.7 into 10 power 308. So if we want to declare this, then we can use keyword double, then our variable name equals to values. So this is all about primitive data types. So our next topic is Java operators. Java operator denotes a symbol that help in performing several operations on one or more than one operands. So Java operator basically a symbol that is used to perform operation on one operand or more than one operand. Operators can be plus, minus, divide, multiplication, etc. depending on the requirement. So here number of operators are available in Java. We can use that as per our requirement. There are different types of operators like arithmetic operators, bitwise operators, assignment operators, tertiary operator, we can say conditional operator, auto increment and auto decrement operator, comparison operators, logical operators, and shift operators. So now we will study about each one by one. Firstly, arithmetic operators. We need to use operators are used to perform several arithmetic operations like plus, minus, modulus, multiplication, and division. The following arithmetic operators in Java. So here, name of operator and symbol, its definition, example are given in tabular form. Firstly, addition. For addition, we use plus symbol. So it helps in adding two values. We can perform addition of two operands. So here A plus B means value of A will be added value of B. Then subtraction, we use minus. It helps in subtracting two values like A minus B. Here value of B will be subtracted from A. Then modulus, and for this we use percentage symbol. It helps in getting the remainder obtained by dividing two values. So it will return us remainder like A modulus B. It will return remainder. For example, our A is 9 and B is 2. Then output will be 1 because here remainder is 1. Then multiplication and its symbol like star, it help in multiplying two value A star B. So value of A and B will be multiplied. And for division we use forward slash. So it help in dividing two values. Here quotient will be returned. For example, similarly, A is 9 and B is 2. Then here result will be 4 because our quotient is 4. So now bitwise operators. Bitwise operators are commonly used in performing bit shift and bitwise operation in Java. So here operation will be performed on bits. So in computer we have two bits like 1 and 0. So now operation will be performed on 0 and 1. Firstly, bitwise and operator. And for this symbol is given in bracket like and. So it helps in comparing two operands. For example, operand 1 containing bit 1 and operand 2 containing bit 0. So and will be return 0. For example, operand A containing 1 0 1. It can be a 1 bit 2 but bit 3 bit as per our requirement. I'm here explaining an example of 4 bits like. So if we want to performing AND operation on this, so in AND operator, if both bits are 1, then 1 will be returned. I'm using here another color, so that's why it will be clear to you. Like, so here 1 and 1, it will return 1 means true. Both are false, then AND will be return false. Here 1 is true, but 1 is false. It also return false. So for AND operation, we have a both value must be true. Although 1 is true, 1 is false, both are false, it will return false. It will return only true when both are true. Similarly, for OR operator, here bits also compared. So here we are comparing bits like we have operand 1. Similar values will be taken for better understanding. So here now we want to perform OR operator. Both are true, it will return true. One, both are true, it will return true. Here one is true and one is false, it will return true. So or in or operator, when both are false, only then it will return false, otherwise it will return true. So next, bitwise Xor operator. It helps in comparing two operands corresponding to bits. One will be returned if corresponding bits are dissimilar, else zero will be returned. So let us understand this with the same example. Like we have a value 1010 and 1001. So now we want to perform Xor operator. So both are 1, it will return 0. Both are 0, it will return 0. One is 1 and second is 0, so it will return 1. So here, if we have two different values, it will return 1. If we have same value, although it is true or false, when we have a same value, it will return 0. So bitwise complement means inverting bits. For example, we have bits like 1010. So here complement, this will be 0101. So it makes 0 1 and 1 to 0. So their symbols are also shown in bracket. Like for bitwise operator, we use line like A or B. So in Xor, we use a power sign like A, then Xor sign B. So complement, we use a tilde sign, tilde B. So our next operator is assignment operator. Assignment operator are used for assigning value to certain variables. So for assigning any value, we use assignment operator. Basically, we use equal to sign. It evaluates the operand of right hand side. So if there is any operation on right hand side, firstly it will solve it. It will evaluate, and then the result will be stored or assigned to variable of left side. So right hand operand can be variable, constant, function call, and expression. And type of right hand operand must be compatible with the type of left hand operand. So both side operands data type must be compatible. So here, like a variable equals to, after equal there can be expression like a plus b plus c, constant any value like 10, function call. So after solving this side, like right hand side, compiler will assign the result to the variable. So there can be operator name like minus equals to. Here firstly will be like a minus b. It will be executed by compiler like a equals to a minus b. So firstly subtraction will be implemented, and then a result will be stored on a. Similarly, in a division, firstly division will be performed, and then a result will be stored in a. For multiplication equal to, firstly multiplication will be performed, and then result will be stored in a. Plus equal to, here addition is performed and result is assigned. Here sign is used to like power. For example, a is 2 and b is 3. So 2 power 3 will be implemented, and then result will be stored in a. And modulus same, it will return remainder here, and remainder will be stored in a. So after performing any operation, the value will be assigned to the left hand side. Then tertiary operator, it also known as conditional operator, and it replaces the if then else condition. So here, if we want to compare two values, then we use a tertiary operator. So in tabular form, operation and symbol, operator name and symbol is given a definition and example. Like firstly, we will write condition. In example, we firstly writing a condition A greater than B. Then question mark. Then we mention our operators A colon B. So A will be returned if a condition is true, B will be returned if condition is false. So this is used to compare two greatest number between two numbers. Then auto increment and decrement. This operator helps in Java in incrementing and decrementing value by 1. So for incrementing, we using plus plus symbol like A plus plus. So if a value of A is 5, then after this value will be become 6. So minus minus value will be decremented by 1. So value minus 1 will be subtracted from value in decrementing. Then our next operator is comparison operator and relational operator. Relational operators are used to make a comparison between two operands. So here relation between two operators will be checked. As from the name, it's clear like a relation operator means it checks the relation between two operands. The result of relational operator is an Boolean value. It can be true or false according to the result. These operators normally we use in if else statements, while loop, do while, for loop, for branching and looping. So here some conditional operators like equal to, not equal to, less than, greater than, equal to, less than, and or equal to. Firstly, we have equal to. Like for example, we writing in table like A equals to B. It will return true when value of A and B will be same. And not equal to, here result will be returned true if both are dissimilar. And if both are same, then it will return false. Less than, for example, here A must be smaller than B, then it will return true, otherwise it return false. And in greater than, value of A must be higher than B. It will return true, otherwise it will return false. In greater than or equal to, it will also check A is higher than B and also check A is equals to B. If A is equals to B, then it return true. If A greater than B, it also return true. But if A is smaller than B, it return false. And similarly, in less than, it also check A is less than B and also check is A equals to B. Then logical operators. Logical operators are used to determine the logic between variables or values. Logical operators in Java are commonly used to combine one or two relations that result in formation of a complex expression. So here we combining two relations, different relations. See in first example like A less than B and B greater than D. So here we combining two different relations. So logical operators to used to combine two or more relations and return some result. Firstly, condition A, conditional and. So in and, when both values will be true, the result will be true, otherwise false. So if B is greater than A and B is greater than D, then it return true. Although one condition is true and another is false, it will return false. If both are false, then the result also false. Then conditional or, here both conditions will be checked. When both are false, then the result will be false, otherwise always the result will be true. And in logical not, it will return inverted. If our result is positive, it will if we have a result 1, then it will return 0, and if 0, then it will return 1. Then shift operator. Shift operator in Java used to shift the bits left or right based on the requirement, like left shift. Here we writing a shift 2. Here 2 bits will be shifted left from right to left, and in right shift bits are shift from left to right. And in unsigned right shift operator, here shifted bits will be discarded and 0 will be appended. For example, right shift, like shifting from right to left. So here two bits from right side will be removed and we append zeros from at these positions. So in left and right shift bits are shifted, but in unsigned right shift, unsigned left shift bits are removed and zeros are appended at that place. There are some other Java operators, some additional Java operators, because these 8 operators we studied in C++. There is some additional Java operator like cast operator, string concatenation, instance of dot operator, and new operator. Firstly, cast operator. So when we have requirement to convert a data type, then we use a type casting. It can be done in manually and automatically. So when we want to go from lower to higher, it will be done by compiler automatically. And in the slide I give you order of a data type. Firstly, higher to lower, like byte is smallest and double is highest. Byte, short, int, long, float, double. So when we want to convert a higher data type into lower, then we have to do it manually. For example, here int a equals to 11 and int d. Now result, when we divide 11 by 2, result will be in decimal. So now we convert int by passing this value to integer. So here I am writing int, then bracket for typecasting. Then string concatenation. So when we want to combine two different strings, 2 or more than 2 strings, then we use a concatenation symbol. We can use concatenation by using plus symbol and using concat method. So here we create a string s and a value stored in this. We want to concatenate two different strings like string Sachin and Tanduklar. So here I am using a plus symbol to concatenation. By concatenation method, we have two different strings, s1 s2, s1 containing Sachin and s2 containing Tanduklar. So now we want to concatenate these strings like and store the result in s3. So now we writing like s1 dot, then our method concate and passing parameter string to s2. So we can use plus symbol and concat method. Then our next operator is instance of operator. We use to check any object, like any object associated with the class or not. We check, we use instance of operator to check, to test whether the object is instance of specific type or not. It will return true or false. If any operator is associated with the class, then it will return true, and otherwise it return false. For example, here we creating a object s of simple1 class. So in second line we check s instance of simple1. So s is object of class simple1, so that's why it return true. For example, we writing here s instance of simple2, then it will return false because it is not a object of simple2 class. So basically this operator is used to check object of any class, that any object is associated with any class or not. Then a dot operator. Dot operator is used to assess a field and methods of an object. So in C++, you learn about classes and objects. So when you have to call any method, you use object name dot function name. And when you want to assess any field, we use object dot field name. So dot operator is used to assess our fields and methods. So firstly, s dot roll number. Here roll number is our field and get data is method. So s dot get data. So dot method is used to assess field and methods. Then the last one operator is new operator. New operator is used to create object of class or an array. So we use new operator to create object of our class. Firstly, we writing a class name and then object name equals to new keyword and class name. So new keyword is used to create object of a class. So here student is our class, as is our object, and new is used to create object of a class. So that is all about operators.